हाउ आर यू ऑल? कैसे हैं आप? ओके, वेरी गुड. हैव यू गिवन एग्जाम टुडे? ओके. हाउ वाज इट? नॉट दैट गुड. एंड व्हाट अबाउट यू, रितु? फ्रॉम विच JNV you are, Ritu? Wait for 1 or 2 minutes. After that, we will start. Okay. Uh, have you solved this question? The first question that was from error. Have you solved this question? Anyone? The question says, okay, you have solved it. Percentage error in measuring length, width, and thickness of a sheet is like this. Then percentage error in its volume, they are asking. So first of all, we should know volume is what? L into B into H. That's what is volume. So I have told you percentage error in the volume will be delta V over V. And for percentage, we will multiply with 100 is equals to delta L by L into 100 plus delta B by B into 100 plus delta H by H into 100. The value of respective percentage error is given as delta in the length, it is given as 2% plus 2% plus 0.5%. So it will become 4.5%. So which is our option number C, which is a correct answer. Very simple, easy question. No problem with this. Moving further for the next question. Okay, this is a good question. The question says the area of, for example, they are saying that there is a graph of area versus displacement. Sorry, area, it's not area, it's acceleration versus displacement is denoted by something. We need to find something like that. If it is like that, then what will be this area? This area will represent what? That's our question. If I say dx over dt is what? V, velocity, rate of change of position is what? Velocity. This has become area. Now, if I integrate it, it will become area under the acceleration displacement graph. So this is the area. Now, if I integrate it, let's suppose we are integrating it from initial velocity v1 to v2. It will become 1 by 2 is taken outside. Integration of v is what? 1 by 2 v square. Limit is from v1 to v2. Can you say it will become v2 square minus v1 square? So area is giving this much of quantity. So identify from the options. If I say it is not impulse, it is not change in velocity, it is neither change in momentum. Now, in the third statement, if I see change in kinetic energy per unit mass, change in kinetic energy per unit mass. Kinetic energy is what? Half m v2 square minus v1 square. This is what change in kinetic energy. So if I divide it with mass, it will become something like that. So this quantity is what? Change in kinetic energy per unit mass. As simple as that. Is the statement clear? How do we get there? Next question. A ball is dropped from a height h on a horizontal floor. Okay. This is a horizontal floor. A ball is dropped from a height h. Very statement is pretty much clear. Goes up to a height h by 4 after hitting the floor. It hits the floor like this. And after that, it goes up to a height h by 4. This height is h by 4. Fraction of energy of ball lost in the impact. What is the meaning of fraction? So fraction, that means they are saying the change in energy divided by original energy. This is the fraction that we want to calculate. Delta E over E. So delta E is the change in the energy divided by the original energy. Hmm. Sorry for the interruption. Actually, there was some technical error. That's why class was cancelled. I think the class was not cancelled. Actually, it was just there is a certain issue with the class. So right now we are continuing the class again. So we have completed this question before the technical error. So now for the next question, we will move towards the next question. What it says, question says a body rotates about a fixed axis with an angular acceleration of 6 radian per second square. What does it mean that alpha is given as 6 radian per second square? 6 radian per second square. That's alpha is given. If angle rotated, if it's not, if the angle rotated by it during the time when its angular velocity increases, that means initial angular velocity is 10 radian per second and final angular velocity is 20 radian per second. So they are asking us to calculate the angle rotated by the body. So theta is what they are asking. So if they are asking about the theta, the thing is, we know that From linear equations, if I compare, we know that v square is equals to u square plus 2as, where s is the displacement. In rotational motion, what it can be transformed? It can be transformed at final velocity, initial velocity, plus 2. Acceleration is what? Alpha. Displacement is what? Theta. Now we need to place the values only. Omega square is what? 400. 400 is equals to omega naught is square will be 100 plus 2. Alpha is what? 6. Theta. So theta will be 400 minus 100, that will be 300 divided by 2 into 6. 2 into 6. You can say it will become 50 by 2, that is 25. 25, which is option number C. I think this point is also clear. Very easy question. Now, there is another question. The moment of inertia of a meter stick. That means there is a meter stick of length. Obviously, the length will be of 1 meter, of mass 400 gram. That means there is a meter rod which has a mass of 400 gram, or you can say 0.4 kg is the mass. About an axis, they are asking about an axis at right angle to the stick, that means perpendicular to the stick, and located at 25 centimeter from one end of the stick. This is the one end and 25 centimeter from it. About this axis, they are asking the moment of inertia. What you know, we know the moment of inertia of this rod about the perpendicular bisector. This is the perpendicular bisector. And we know the moment of inertia about it. Perpendicular bisector means that total distance will be 50 centimeter, out of which this one is 25. So this one will also be 25. Clear? Now we know the moment of inertia about this axis. This is the center of mass of the rod as well, ICM. And about this axis, it is known. It is to be asked. It is asked by the examiner. So what we can do here, from parallel axis theorem, we know that from parallel axis theorem, what we know? We know that moment of inertia of any parallel axis, yeah, about any parallel axis is equals to moment of inertia about center of mass plus mass of the body into d square. D is the perpendicular distance between the two axes. So if I place the value about center of mass, can anyone tell me what is the moment of inertia about center of mass? Do you remember the relation? I'm on standby. You can answer. About about center of mass, it's ml square by 12 plus m. Can you see that this distance is 25 centimeter? So we will place this value in the next step. Now placing the value, we can take m as common. Length is what? Total length of the rod is 1 meter. That means 1 by 12 plus. This separation is 25 centimeter. 25 centimeter can be written as 1 by 4 meter. 1 by 4 meter, if you square it, it will become 1 by 16. Now we need to solve it. Mass is 0.4 kg. And if you take the LCM, it will be 48. 4 plus 3, that is 7. Further, if I calculate it, it will be, you can say 0.1 and 12. That means 7 by 12 into 10 raised to the power minus 1. Or you can say 0.58 into 10 raised to the power minus 1. Now modify the answer according to the options. It will become 5.8 into 10 raised to the power minus 2 kg meter square, which is option number B. Is every point clear in this particular question so that I can move further? Moving further. Current I coming from the battery and ammeter reading R. Okay. Look at the question. First of all, let's suppose there are so many resistors. Let's name it R1, R2, R3, and R4. No problem with that. Each resistor is of 4 ohm. So when I say, just look at that, R1, R3, and R4. They all are in parallel combination. The name I am telling you, R1, R3, and R4 are in parallel combination. If they are in parallel combination, their equivalent resistance R dash or R will be each of 4 ohm, that means 4 by 3 ohm. This R is in series with the R2. So next step I will write R and R2 are in series. I hope that you can identify this situation. Why they are in parallel, why they are in series. If they are in series, so R equivalent will be 4 by 3 plus 4, that is 16 by 3 ohm. If R equivalent is 16 by 3, that means total current supplied by the battery I is equals to total potential is 2 volt, total resistance is 16 by 3, or you can say 3 by 8 ampere. You can find that 3 by 8 ampere total current supplied by the battery is 3 by 8 ampere, which is in option number A, 3 by 8 ampere. Now, what are they saying? They are saying that what will be the current in the ammeter as well. We can cross check it as well. 3 by 8 ampere is coming this way. This current will reach 1 in this resistor, in this resistor, and in this resistor. This current will divide in 3 resistors. All 3 resistors have same resistance and same potential. That means current will also be same. So if you divide 3 by 8 in 3 equal parts, it will be 1 by 8, 1 by 8, 1 by 8. So current in this ammeter will be 1 by 8 ampere. So which is correct for option number A. This is again a very simple question. Now there is one thing that some of you might do wrong in it. Question says when a resistance 2 ohm is placed, resistance of 2 ohm is placed across a battery like this. Battery has some EMF E. The current is 1 ampere. So the question says current is 1 ampere. So some of you might feel that current is given as 1 ampere. Resistance is given as 2 ohm. Then we can easily calculate the EMF. But question is not that easy because in the next condition it says what it says. In the next condition it says when a resistance of 17 ohm is connected with the battery, current becomes 0.25 ampere. What you understand from 0.25? Is it 1 by 4? Current becomes 0.5 ampere. That means 1 by 4 ampere. Now, there must be some internal resistance. There must be some internal resistance. So internal resistance, I told you that always affix it with the negative terminal. So for the first diagram, if I say I is equals to EMF E divided by total resistance is what? 2 plus R. 2 is the external resistance, R is the internal resistance, so total resistance is 2 plus R. This is what current, and current is given as 1 ampere. Current is given as 1 ampere. So you can say that 2 plus R is equals to E. That is our equation number first. For second diagram, what you can conclude that current is equals to, that is 1 by 4 is equals to EMF is E divided by resistance is 17 plus small r. So you can again cross multiply it. You can say that 17 plus R is equals to 4E. 17 plus R is equals to 4E. This is our equation number second. We can solve it. Minus, minus, minus. Minus 15 is equals to minus 3E. Minus, minus will be cancelled. So E is equals to 5 volt. So EMF of the battery is 5 volt. Very simple question. Should I move ahead? Which formula we have used in this term? I is equals to E upon R plus R. This is nothing but Ohm's law. What Ohm's law says? Current is equals to total EMF upon total resistance. Next question. This is a very important question. Question says a condenser, that means capacitor, of capacitance 10 microfarad is charged. That means there is a capacitor which has a capacitance of 10 microfarad, is charged by a potential of 500 volt. That means it is charged by a potential of 500 volt like this. Clear? Then during the charging, how much charge will it acquire? How much charge will it acquire? You will say, sir, Q is equals to C delta V. We know that charge on the capacitor will be C delta V. I think this formula you remember now. So if you C delta V product, if you solve it, C is 10 microfarad, delta V is 500. Can you see that it will become 5000 microcoulomb? Is it clear? The charge on the capacitor during the first statement, if I say charge on the capacitor is 5000 microcoulomb. Now it again says its terminals are then connected to those of an uncharged condenser. Condenser means capacitor. This charged capacitor of 10 microfarad is now connected with a uncharged capacitor of 40 microfarad. Clear? This is the question says. Now, the loss of energy in connecting them. So first thing that you should remember, after this connection, the potential of the first capacitor, like this is C1 and this is C2. The potential of the first capacitor will change, and they both will become or will come at a certain potential, which is known as common potential. And that common potential is given by a golden relation. Common potential is given as total charge on the system divided by total capacitance. So common potential is what? Q total over C total. So Q total on this system, this was uncharged. This was charged by what amount of charge? 5000 microcoulomb. So total charge of the system is 5000 microcoulomb. Divided by total capacitance is what? 40 plus 10. That is 50 microfarad. You can see micro and micro will be cancelled. 0 and 0 will be cancelled, and you can say it will be 100 volt. So common potential of this system is 100 volt. Is this thing clear? You can mark it as important formula, common potential. Whenever two capacitors or two conductors are connected, there will be a common potential thing. That common potential will be given by this quantity, this relation. After moving Now we can move further. What it says, the loss of energy in connecting them together. Let's suppose this is our initial situation, this is our final situation. So first of all, we will calculate U initial. Capacitance is given as C, potential is delta V. So we know that the energy stored in the capacitor is half CV square. So that will be half CV square. If I place the value half, C is what? 10 microfarad. Micro, remember in your mind. Potential is what? 500. Potential is what? 500. If you square it, 5, it becomes 25. 1, 2, 3, 4. Clear? You can solve it. 5. So U initial will become 125, 1, 2, 3, 4 zeros. And 10 to power minus 6. 1, 2, 3, 4, 5, 6. That is 1.25 joule is the initial energy. Calculation you can recheck with yourself. Initial potential energy or initial energy stored in the capacitor is this much. Now final energy stored in the capacitor will be, you will say U final. Finally, there are two capacitors. Both will store some energy. So you can say half C1 into potential is V square plus half C2 into potential is again V square. Now you can see that I have put the potential same because both the cases potential is common, which is 100 volt. What you can take common, half is common, V square is common, becomes C1 plus C2. Now place the values. Half V square is 100 square. C1 plus C2, if you say, it will become 40 plus 10, 50 into 50 into 10 raised power minus 6. If you solve it, this is again 25. 1, 2, 3, 4. So U final is what? 25, 1, 2, 3, 4. And power minus 6, 1, 2, 3, 4, 5, 6, that is 0.25. So change in potential energy or change in energy is, you can say initially it was 1.25 joule. Now it is 0.25 joule. So what is the loss of energy? Loss of energy is 1 joule. Loss of energy is 1 joule, which is which is option number A. I have hidden the option completely, I think, which is option number A. Is this question clear? Now, sometimes it may ask or they may ask, where is this lost energy? This lost energy is lost in the form of heat. While the charge is transferred from one capacitor to other, when you connected the uncharged capacitor will get charged. And during the process, some energy is lost in the form of heat because charge is flowing through the wire and some heat is produced. So this energy is lost in the form of heat. Now, can you answer this question? Can anyone answer this question? This is the simplest or easiest question of this question paper. It involves the direction. First thing, there is a conductor AB. This is the conductor AB. Length is given somewhat. Current I is in this conductor. So what it says, there is a conductor of infinite length which has a current I, and another conductor is placed like this, which has a current in this direction. Clear? This is capital I something. And you want to calculate the force on this wire AB. And if you want to calculate the force, first of all, who will exert force? This infinite wire. Let's suppose this is wire 1, this is wire 2. So wire 1 will exert force. How it will exert force? Wire 1 is creating some external, some creating is some field, some magnetic field. and the direction of that magnetic field using right hand thumb rule, you can identify the direction of this field will be inward, or I will say using right hand thumb rule, we can find the direction of B1, which is going to be inward. B1 is what? Magnetic field of first wire. Now, the second wire is placed in this inward field. Using again right hand thumb rule, I am not using my right hand thumb rule because the image will be mirrored. So you may feel some difficulty in that. The if I place my force is what? I L cross B. So if I place my right hand fingers in the direction of current of the wire AB, IL, field is in the inward direction, that means inward. So thumb is in the downward direction. Thumb is in the downward direction. This point is mentioned as M, this point is mentioned as N. So the direction of force will be along N to M. Along N to M means the option number B is correct. This is easiest question, right hand thumb rule. If you know right hand thumb rule, then there is no problem. But if you don't know, you can ask me or you can ask whoever is near to you. Again, the simple question figure shows a conducting loop PQR carrying a current I. Okay. So they are asking this is a very difficult type of form they have formed. There is a parabola and lot of things student may leave this question. But remember one punchline. Magnetic force on a loop in uniform magnetic field. In uniform magnetic field is always zero. They have given you a parabola thing. The thing is that whenever there is a uniform magnetic field, let's suppose this is a uniform magnetic field B, and in this field, any loop is placed which has any random shape, whatever the shape may be, but it has some current. But the net force on this loop will be zero until this is a loop and field is uniform. Both conditions are satisfied, then force will be zero, which is again option number A. You don't need to solve anything. This is a key punchline. Moving further. Network shown in a figure is a part of the circuit. The battery has negligible resistance. At a certain instance, the current I is 5 ampere and it is decreasing at a rate of something given as rate. What is the potential difference between B and A? Now listen. Very simple question. Just start from A and move towards B and apply Kirchhoff's law, Kirchhoff's voltage law. Write all the potential differences while going from A to B, and you will get the potential difference of A and B. So what I'm saying, delta V, I am going from A to B. That means I am writing it VA minus VB. VA minus VB is what? First of all, there is a resistor of 1 ohm. Current is 5 ampere. That is I into R. 5 into R is 1 ohm. Is my screen visible to you now? Is it so? Okay. I think it's visible now. Okay. Now, what I was saying that while moving A to B, I am moving in the direction of current. That's why I have taken it positive. Now there is a battery. I am entering the battery from negative terminal, so it is minus, and EMF is minus 15 again. Now there is a inductor, and EMF induced in the conductor is minus L di over dt. EMF induced in the conductor is minus L di over dt. That is minus L is what? 5 millihenry. Di over dt, it is given as rate of changing in the current is 10 to power 3. That is 10 to the power 3. So this is what total potential difference, 10 to power 3 and minus 3 will be cancelled. This is 5 plus this is 5 minus, it is also cancelled. So this is minus 15 volt. And this minus 15 volt is what? VA minus VB. We want to calculate VB minus VA. They are asking potential between B and A. So VB minus VA is 15 volt. So which is option number B? Which is option number B? Moving further. Again, they are saying there is a alternating voltage, something like this. And this voltage is applied to a capacitor of 1 microfarad capacitance. There is a capacitor as well, which is 1 microfarad. The current reading of the ammeter, whenever they are asking the current reading means they are asking the RMS current. What is being asked here? RMS current is asked. Clear? So RMS current, if they are asking, the RMS current will be, Ohm's law says I is equals to E over R. I is equals to what? E over R from Ohm's law. But EMF, we should place RMS EMF. And resistance of this capacitive circuit is denoted by capacitive inductance, capacitive reactance, or you can say capacitive reactance denoted by XC. Now, again, if I move ERMS over capacitive reactance is what? 1 over omega C. 1 divided by omega C. Omega C will go there. So this is the final solution that we want to calculate. Omega is given according to the question. The EMF is given as 200 root 2 sine 100t. I think you remember the original equation. This is given as V is equals to, I think you know the original equation. V is equals to V naught, or E is equals to E naught sine omega t. This is the original equation. Comparing, you can get omega is equals to 100. Capacitance is given. And ERMS we can calculate. ERMS, if I calculate, ERMS is E naught upon root 2. I think you remember the formula. E naught is what? 200 root 2 divided by root 2. E naught is what? 200 root 2. Root 2 will be cancelled. E naught, ERMS is 200. Now place the value. IRMS is 200 divided by. Why I am dividing? 1 is not to be divided. Into omega is what? 100. Capacitance is what? 1 microfarad. That is 10 raised to the power minus 6. So that will be 1 0, 2 0, and 3 0 if I cancel. If I cancel these 3 0, it will become minus 3. So that is 20 into 10 raised to the power minus 3. That is 20 milliampere. Why I cancelled only 3 zeros? Because answer was asked in milliampere. So I want power minus 3 to remain there. That's why I have cancelled only 3 zeros. So 20 milliampere is the answer. So that is option number A. Clear, I think. Moving further. Now, this is a very good question. Can be solved by two ways. I am solving using the simplest method because another concept I think you have not studied that. So the question says there is a equiconvex lens. Equiconvex lens of some focal length 10 centimeter. Clear? Focal length is given as 10 centimeter. Equiconvex means both of the radiuses are same. Both the surfaces, there are two surfaces, now both the surfaces have same radius. Okay. This is the principal axis. Very good. Now, next statement says refractive index is 1.5. We will keep it in mind. Now, one of the surface, one of its face is silvered. Like suppose this face is silvered. Okay. And for an object placed at a distance u, let's suppose there is an object which is placed here, u, at a distance u. In front of the image, in front of it, the image, there should be a comma. The image coincide with the object. The image of this object is coinciding with this object itself. Where what is the value of u they are asking? So now listen very carefully now. For the image formation, we need at least two rays. We need at least two rays. Let's suppose first ray is this one. If I can draw it with some other color pen, let's suppose first ray is starting and going this way. The ray is passing through these, first of all, it is passing through a refracting surface, then the reflection takes place and it will returns back. Why it's returning back? Because it is going perpendicular to the surfaces. Whenever it is perpendicular, it will return back. This is the punchline. This is the punchline, you know now. Now, the second ray I am taking, this is the second ray. After reaching the surface of the lens, it will suffer some refraction. I will draw diagram more clearly. This is very bad now. Previous one was good actually. It will suffer some refraction. And you will say it will bend towards normal and it will go something like that. I hope it's visible that it has bended something. There is some bending in it. Now listen to me. The image is ultimately formed at a point where the final rays will meet. Where the final rays will meet. But the question says the image should form at the object itself. That means this second ray, this yellow color ray, should return back to the same point O. And it will retrace its path. It will reverse its path, or you can say retrace its path. The actual term is reversibility. It will reverse its path if it strikes the mirror perpendicular to the mirror. If it strikes the mirror, this is the mirror now. If it is striking the mirror perpendicular to it, then it will return back or reverse its path. So for that purpose, this ray should be striking the refracted ray, I'm saying, should be striking the mirror perpendicular to it. And if it is striking perpendicular to it, that means it should be coming from its center of curvature. It should be coming from its center of curvature. And this is the center of curvature I have assumed C. Okay, so till now every point is clear. So what we need to do, we need to find this radius of curvature. This is C distance. So we can use it by lens maker formula. Lens maker formula. What is the lens maker formula? Lens maker formula says 1 over f is equals to refractive index of lens divided by refractive index of surrounding minus 1 over R1 minus 1 over R2. This is the lens maker formula. I hope you remember this. Now I am placing the values here. 1 over f, focal length is given as 10 centimeter. Lens refractive index is 1.5. Surrounding is air, that means 1 minus 1. 1 by R1, both are equiconvex lens. That means both have same radius of curvature. Both faces have same radius of curvature. That will be 2 by R. 1.5 minus 1 will be 0.5. 0.5 means 1 by 2. So 1 by 2 will be cancelled by this 2. Doing it very quickly now. So R will become 10 centimeter. What does it mean? This is surface 1, this is surface 2. This means image of first surface is at 10 centimeter. I am talking about the image of first surface only. Now, using another relation, refraction at spherical surface. We know that for first surface, image position is known. Now we want to calculate this object position for the first surface. And if I want to calculate this object position, for that, I am applying the relation refraction at a spherical surface, which is refraction medium. I am not going to write the formula. I hope you remember. Refraction medium over image distance minus incidence medium over object distance. I'm writing it. Refraction medium is 1.5 divided by image distance is what? Minus 10. For first surface, I am writing. Minus incidence medium is air. Object distance is u, is equals to refraction medium minus incidence medium divided by r. R is what? 10 centimeter. So if I solve it, 1 by u I am transferring here is equals to, you can say this is 0.5 by 10. So this is minus 1.5 by 10 minus 0.5 by 10. Can you say it is minus 2 by 10? That is minus 1 by 5. So u is equals to minus 5 centimeter, where minus sign indicates to the left and 5 is the magnitude. So which is the correct option? Which is option number B. So what you can learn from this question, that whenever the image is coinciding with the object, that means the two rays that you have started from the object must terminate at the object itself after the reflection or refraction, whatever is happening. One thing. Next thing, the image will reverse its path. You know that there is a mirror. If there is a mirror, if I strike a light perpendicular to it, then it will retrace its path. You know that. In case of concave mirror, I hope you know that this is the center of curvature. the ray which is going from center of curvature will be returned back. Why? Because center of curvature, this is becoming radius. So radius is always perpendicular to the surface. So perpendicularly light, if reached, then it retraces its path. That's why I'm saying that if rays should reverse its path, then it must be coming perpendicular to the mirror. That's why it should be coming from the center of curvature. This is it. I think time is up. I have another class. So there are few questions more. Okay, lot of questions are there still remaining. Okay, we will discuss them later. Till then, I am ending the session. Bye, everyone.